All right, guys, so in 2.6, we're going to be looking at two different types of special functions. The first one is called a piecewise defined function. Piecewise means that they're kind of separate pieces of different graphs put all together onto one graph. So you can see if we look at this first example, f of x is defined as being two different functions. It's the function x minus 1 for these specific x values, and then it's the function negative 1 for these specific x values. So it's almost like someone cut and pasted different graphs like onto the same coordinate system. So you're going to see what they look like when they're done. So we're going to set up a graph right here. So 3 is kind of our splitting point. So 1, 2, 3. So we've got from x is less than or equal to 3, and then x is greater than 3. So you're going to have one graph over here and then a different graph over here. Okay, so let's start with this one. So what you want to do basically is you want to look at this value and see where this function would be when you plug in this x value. Okay, so if we plug 3, so like 3 is kind of our defining piece. If this is 4, we'd be plugging in 4. We're plugging in whatever this value is right here. So we're going to plug in x equals 3 into this first function right here. So x minus 1 becomes 3 minus 1, which is 2. So that means the first one has an ordered pair at 3, 2. Okay, so this is less than or equal to 3. So we're going to plot the point 3, 2, and it's going to be a closed point, because that has the or equal to. Okay, kind of like when you're working with a number line, closed and open are the same as having the or equal to or not having the or equal to. Okay, so we plot a closed point, and then from there what we're going to do is we're going to take a look at the slope. Okay, so this is the first function. So like here's the first one, here's the second one. So for the first one, we start with our starting point right here. It's closed because that has the or equal to, and then the slope of this line is 1. Technically, there's a 1 in front of that x. So the slope is 1. So what you do is you go off to the right, you pick any arm side, you go off to the left since it's less than or equal to 3, and we plot a slope of 1. So for a slope of 1, we're going to go down 1 over 1, down 1 over 1. We can do it one more time, down 1 over 1, and then you're just going to connect the dots and make a graph. Okay, so it extends forever off to the left because it's anything less than or equal to 3. So I could plug in 3, 2, 1, 0, any negative number. So it keeps on going forever off to the left, but it stops right here when I get to the 3 because that's the boundary that I have right here. So for my second piece, I start at -3. And since this is a -1, just a -1, this is actually a horizontal line. Okay, so it is a horizontal line at -1. That means the function is always -1, no matter what you plug into it. So we're still starting at 3, but see how this is a greater than 3, not a greater than or equal to. So we're going to start at -1, but we're going to start there with an open circle. So open circle, and then from that point on, it is just a horizontal line where the value is always -1. So this is our first example of a piecewise function. So hopefully you can kind of see what I mean when I said it looked like it was literally, a cut and pasting of different functions onto the same coordinate system. So here's the graph x minus 1, but just up until we hit 3. And then here's the horizontal line -1, starting at 3 and then going beyond that point. Okay, so that's the first one. Let's look at the next one. Next one, we've got 3, and we're going to, oh, I'm sorry, I missed something on here. Domain and range. Domain and range, so we're talking about all the possible x values, all the possible y values. So the domain with these, it's always going to be all reals. You can at some point find a place to plug in every possible x value. So here, combining these two ends up covering every x value ever. And then the range is the part that gets a little bit tricky. Once you've got the graph in front of you, you should be able to see what y values are getting hit and what y values are not. So you can see, I would kind of scan up and down, see if there's a high point and a low point. So this is the high point. You're never going to have a higher y value than this. See, there's nothing plotted above this point. And then this arrow means it goes down forever. So 2 is the highest possible point, and then it goes down from there. So you would say that you can hit anything less than or equal to 2. You can hit 2 and anything lower than that, but never anything above that. So that's the domain and range. All right, now let's look at example 2. So we've got 3 pieces for this one. So let's set up a big graph. and we'll start to look piece by piece. So for piece number 1, 0 is kind of your cutoff point, so we're going to plug in 0. So we plug it in, x over 3 becomes 0 over 3, which is 0. So when we plugged in 0, we got 0. So that means we have a coordinate point at 0, 0. So let's start there. Okay, we're going to plot this point right here. We have less than or equal to, so it's going to be a closed circle. And then less than or equal to means we graph off to the left. Now let's take a look at slope. X over 3 is technically like 1/3 times x, so our slope is 1/3. So what we're doing to get more points is we're going to go down 1 and then over to the left 3. That's 1 point. Let's do it one more time. Down 1, over to the left 3. There's another point. Okay, so our graph goes off to the left. Arrow means it goes off forever, because anything less than 0 means it just keeps going and going in that direction, but it stops once it gets to 0, and we have a closed circle because that has the or equal to right here. Okay, next piece. So here's our first piece, second piece, third piece. Our second piece is the 2x minus 6. So we're actually going to plug in both of these points. So remember, the 3-piece inequality means everything in between. So it's going to be in between 0 and 2. So it doesn't go on forever in both directions. It's just going to be trapped between the 0 and the 2. So we're going to plug in the 0. So we plug in 0 right here. So 2 times 0 and then minus 6 leaves us with negative 6. So you have the coordinate point 0, negative 6. So let's start with that. So right there. Now at 0, there's no or equal to, so this is going to be an open circle. And then let's connect it to the 2. So next, we plug in the 2. So 2 times 2 is 4, minus 6 is negative 2. So our second ordered pair is 2, negative 2. Okay, so that is right there, and that's a closed circle because this does have the or equal to. And now 3-piece inequality means it's just connected between those 2 points. So we just connect the dots, and that's it for a 3-piece inequality. And then we have our last piece that goes to the right from 2. Okay, so this is just 1. There's no x in there at all. So if it's just a number like that, then it's going to be a horizontal line. Okay, so horizontal line at 1. So it picks up at 2, so go up to 1. We start here with an open circle because that does not have the or equal to, and then it just goes on forever off to the right. So 2-piece inequalities will always have arrows going off to one side. 3-piece inequalities will just be a segment like that, just trapped in between the 2 pieces. Okay, so that's the piecewise function. Absolute value function. We will do a lot more with this absolute value function in both sections 2.7 and 2.8. But for now, we're basically just plotting the absolute value stuff that we learned about in 2.4 and then did some more with, in 1.4 and then did some more with in 1.6. All right, so our function looks like this. F of x equals the absolute value of x. And we know how absolute value works. If you plug in a positive number, it comes out positive. If you plug in a negative number, it still comes out positive. Okay, so it's going to look like this. Let's make a table. X, Y. So here's a great number of values to use. If you go -2, -1, 0, 1, 2. So you guys are going to be making some tables in this section. These are the x values that I want you to plot. So -2, if we plug -2 into this function, absolute value of -2 is 2. Now plug in -1. Absolute value of -1 is 1. Now plug in 0. We're just plugging them all into this function, finding the y value. Absolute value of 0 is 0 because it's not any distance away from itself on the number line. Then 1, absolute value of 1 is 1 unit from 0. And 2 is 2 units from 0. So we're going to take those 5 points, we're going to plot them. I'm going to show you what this graph looks like. Okay, so start with the point -2, +2. So -2, +2 is right there. Next, the point -1, +1. So from the origin, -1, +1. then the point 0, 0, right at the origin, then 1, 1, so over 1, up 1, and 2, 2, so over 2, up 2. So these are the 5 points, and so when you connect the dots and keep the graph going out to both sides, you'll notice that it just has this V shape. So it's like this part of it looks like a normal line, and then when you get over here, that line flips, because it gets flipped above the x-axis where everything is positive. Okay, so that's what your absolute value graph looks like. It looks like a V. The normal one is centered right at the origin, but we're going to do some examples here where we make some changes to it. So the way that you guys will be graphing these in your homework is just by plugging in to this table that I gave you right here. All right, so an XY table, just use those 5 values, -2, -1, 0, 1, 2, and you just take those 5 values and sub them in for x into this equation. Okay, so absolute value of -2 minus 2. All right, so -2 minus 2 is -4. -4 is 4 units away from 0. Okay, so I plugged in -1 for x. -1 minus 2 is -3, which is 3 units away from 0. Now plug 0 into that absolute value. 0 minus 2 is -2, which is 2 units away from 0. Now plug in 1. 1 minus 2 is -1, which is 1 unit away from 0. And plug this in. 2 minus 2 is 0. Okay, so let's plot what we've got here. Okay, so we have the point -2, 4, which is right here. -1, 3. -1 up to 3. 0, 2 would be right on the y-axis. 1, 1 is right here. And the point 2, 0 is on the x-axis. So now this doesn't look like our V shape yet. So let me show you what happened if we plugged in just one more value. So we plugged in a 3. 3 minus 2 is 1, which is 1 unit away from 0, and that's when the graph turns around. So now we can plot like this. There's the left side of the V, and the right side is just going to keep going up. If I plugged in 4, 4 minus 2 has an absolute value of 2, so it's just going to keep going up from here. So this looks the same as this. It's just like I picked it up and moved it over here. All right, one last one. We're going to make the exact same table, just plug that in. Okay, so take those 5x values and just take turns plugging them into the equation. Okay, so remember with absolute value, I can't distribute that negative. I take the absolute value, then I make it negative. So -2 is 2 units away. Make it negative. So -2 plus 1, which is -1. So I'm going to start plotting as I go. So -2, -1 is my first point. Then plug in -1. Negative absolute value of -1 plus 1. So this is 1, which means the whole thing is -1, and then plus 1 gives me 0. So -1, I'm right on the x-axis here. Now plug in 0. Negative absolute value of 0, that's just 0. Plus 1 gives me 1. So I'm right here on the y-axis. Plug in 1. Negative absolute value of 1. Plus 1. So this is -1. Plus 1 gives me 0. So 1, I'm right back on the x-axis here. And my last one, 2. Negative absolute value of 2. Absolute value is just 2, so the negative absolute value is -2. So -2 plus 1 is a -1. So that is my last point on the graph there. So you can see the V shape. Notice that the V shape is upside down. We'll talk about why exactly that happened in the next section. Notice it's also 1 unit up. Our original graph started at the origin. All right, so that is your absolute value and step function stuff.